Okay, let's talk about finding slope given 2 points. So we know that slope, if we're looking at a graph, is easy and fun. It's rise over run. So from this picture that I have here, I could determine how many I rise and how many I run. But let's talk about where that comes from, because what we really want to be able to do is derive a formula that we can use when we're given 2 points so we don't have to graph them out. Especially because sometimes we can't get a hold of graph paper and it's kind of a pain to have to graph it out every time. So how can we do it without that? Okay, so we know it's easy and fun, it's rise. So how do I know how much I rise? Well, I can count, it's 1, 2. But what about if I looked at my points? Well, that rise, isn't this here 3? Let's see. So if right here, if I can mark it, is a y value of 3, couldn't I say that this y value of 3 minus this y value of 1 is what gives me that rise of 2? Couldn't I also say my run right here comes from taking this x value of 4 and subtracting this x value of 1, if I label this point here, maybe that's a better way to do it. Couldn't I say that that comes from taking 4 minus 1, and that's what gives me the 3? Okay, so my rise is 2, my run is 3. I got that from taking to find my rise, I took one of my y values, and I subtracted the other y value. To find my run, I took one of my x values and subtracted my other x value. Okay, so why is that important? Again, because every time I'm given 2 points and I'm asked to find the slope, I don't want to have to graph them out. So here's the equation I'm going to use. Here's my formula for slope. It is imperative that you remember this. You are going to use this formula when you have 2 points. So instead of saying, like I did up here, y minus y and x minus x, we want to differentiate that they're different y's and they're different x's. So we are going to be taking 2 points. Say the first point has our first x value, call it x1, and our first y value, call it y1. And my second point has my second x value and my second y value, x2 and y2. That's all those little subscripts mean. Okay, so to find my slope, remember slope is m, I take y2 minus y1, just like I did up here. To find my rise, I took my second y value, my 3, and I subtracted from it my first y value, my 1. Okay, so then what do? Well, it's rise over run. How did I find my run? I subtracted my x values. I subtracted my second x value for reading from left to right minus my first x value, so x2 minus x1. This is the formula we're going to use. I would strongly encourage you to, each time you're doing it, write this formula down, because what I see students do all the time when they get to the test is they forget which variables go on top and which variables go on the bottom. I will take points off every single time you make that mistake. You have to get this formula down. Rise is on the y-axis, run is on the x-axis. Therefore, rise over run. Subtract the y's over the x's. So let's look at some examples with this. Okay, here's the other thing I'm going to encourage you to do. When you're given your 2 points, label them x1, y1, x2, y2. It helps to keep it straight when you plug it into the formula. So now, how do I find my slope? Well, I do y2 minus y1 over x2 minus x1. Notice I'm not graphing anything. I'm just using the formula. Well, y2 I've already labeled, it's -4, minus my y1, which is -3, over x2, which I've labeled as -1, minus x1, which I've labeled as 2. Well, from here, I know that when I have minus a minus, that is going to become plus. So I have -4 plus 3. Well, that equals -1. -1, subtract 2 more. That equals -3. -1 over -3, of course, reduces to 1/3 since a negative over a negative is positive, and we always write things in our simplest form. Let's look at the second example. Same thing. I'm going to start by saying I have an x1 and a y1, an x2 and a y2. I write a little bit bigger than I type, so normally that should be lined up. From here, so what do I do when I have 2 points? Well, I do y2 minus y1 over x2 minus x1. Since I've labeled them, now I just plug in what I've labeled. My y2 is -6 minus my y1, which is 6, over my x2, which is 3, minus my x1, which is 0. Okay, from here, be careful. -6 minus 6. If I'm in the whole 6 and someone takes 6 more from me, I'm in the whole 12. 3 minus 0 is just 3. -12 over 3 reduces to -4. So my slope, m, is -4. One final example. If you feel like you've got it, feel free to skip the third example. But I really do strongly encourage you, even if you've got it, to make sure you're labeling your points and writing out your equation. I promise some of my smartest students have still made mistakes once they got to the test because they haven't got this down as much as they think they have. So that's got to be just, you got to have that down. You got to have it memorized. It's got to be at the top of your head, top of your memory. Okay, example 3. This is also a good one to try if you want to see if you've got it, and then go ahead and pause and see where, if anywhere, you're making mistakes. Okay, so I have x1, y1 to start with, and x2, y2. My equation y2 minus y1 over x2 minus x1. Plugging my 5 in for y2, my 1 in for y1, my 7 in for x2, my 4 in for x1. I know that 5 minus 1 simplifies to 4. I know 7 minus 4 simplifies to 3. 4 over 3 cannot be reduced, so that is my final answer. That is my final slope.